Welcome all. Today in building services we will know about the concept of the pressure temperature relationship for the liquids. That is why the pressure temperature relationship for liquid is necessary to be understood. That is how the pressure of the liquid changes with respect to the varying temperature, which will be helpful in the designing and operating different equipments in the building services. Pressure temperature relationship, that is the pressure of the liquid changes with respect to the temperature under different conditions. So unlike gases, liquids are nearly incompressible, that is their volume changes very little with the pressure. However, this temperature affects the properties of the liquid, such as the vapor pressure, boiling point, density, viscosity and the thermal expansion. So understanding this relationship between the pressure and the temperature is necessary in order to design and operation of the boilers and hot water systems, pumps, pipelines, pressure vessels and HVAC systems in the building services. For liquid, pressure and temperature are related mainly through the two things, that is, one is the vapor pressure and other one is the boiling point. Next is the effect of temperature on the pressure. So when the temperature of the liquid increases, the kinetic energy of its molecule increases. So more molecules will escape from the liquid surface, increasing the vapor pressure. If the liquid is contained enclosed in the rigid container, then the internal pressure will rise with the temperature. That is, when the liquid is in the open space, that is, the lot of molecules will escape from the liquid surface, which will increase the vapor pressure. When the liquid is contained in the rigid container, so there will be also the higher pressure, which is the higher internal pressure in the closed systems when there is a rise in temperature. Next is the effect of pressure on the boiling point. So the boiling point of the liquid depends upon the surrounding pressure. That is, when higher pressure increases the boiling point and lower pressure decreases the boiling point. So a liquid boils when its vapor pressure equals the surrounding pressure. For example, so water boils at 100 degrees Celsius at the atmospheric pressure, and in the pressure cooker, which is in high pressure, water boils around 120 degrees Celsius. Similarly, at high altitudes, so lower pressure, water boils below the 100 degrees Celsius. So this is about the effect of pressure on the boiling points. So the boiling point of the liquid varies with respect to pressure of the liquid. Next is about the thermal expansion of the liquids. So when the temperature increases, the molecules will start moving faster and the liquid volume also increases, but the density decreases. So the volumetric expansion can be calculated by using this formula, that is delta V is equal to beta into V naught into delta T, where delta V is the change in volume of the liquid and beta represents the coefficient of the volumetric expansion, and V naught is the original volume of the liquid and delta T is the temperature rise. Next is about the vapor pressure. Vapor pressure is nothing but the pressure which is exerted by the vapor above the liquid which will be in equilibrium with the liquid. So the characteristics of the vapor pressure is it increases when the temperature increases. So that is increases with temperature, but it is independent of the liquid quantity, but it depends on the type of the liquid. So higher vapor pressure indicates the greater volatility. This is the characteristics of the vapor pressure. Next is the advantages of understanding the pressure temperature relationship. By understanding the pressure temperature relationship, we will be able to operate the boilers safely, that is the safe operation of the boilers and efficient hot water distribution, and we will be able to select the required proper pump which is required for our operation. So proper pump selection and also the reduced risk of the pipe failure and improved energy efficiency, longer equipment life and better pressure control and enhanced system reliability. Limitations. So the liquid cannot be compressed significantly, then excessive temperature may lead to rapid vaporization, and higher pressure requires stronger and the costlier equipments, and thermal expansion can damage the pipelines if not controlled.